Welcome back. This is called relative path. So we can give instead of giving we don't know, right, where you'll put your folder. If you give the relative path, it will fetch. So let's forward slash. It will search for this folder. It should be working in real time. It will work. Two dots. Yeah, we can see because we don't know, right, where you'll put your. Let us assume this is your project folder. Okay, and you put that in wherever. So every time you change your location, so just this called relative path. Just put double dot backslash your project. Sometimes you will not put in your this fragment, whatever you're saving. You may be putting in some other path where it could be like shared path. You can put that here. So it will, and multiple people can access this. Like, you have created, right? Another tester, they will also create their script from their laptop, right? So all people can access this uh, uh, from the different location, but everything should be in the same network. So normally when you work in a project, you have access to your share path, your project path, right? So normally we'll put that in a shared drive and we'll just run. Instead of giving a physical path, always try to give the relative path. Now you can see, even if I run with multiple scripts, it will take. So this is called fragmentation of your script. In real time, this is really useful when you do this test fragmentation. Okay, and I think we have covered almost all. Parallel control also we have covered, include, while. Then we move to timers. Okay, so timers. Okay, timers is just like, if I want to put any time interval between action to action. So let us say here we have these many requests or steps or actions you say, right? In real time, how the users will access once you launch, at least you wait for some time, right? Few seconds in real time, then only this will be executed. After that, this will be executed. After that, this will be executed. Like that, it will be executed at least taking 1 or 2 seconds time. If I want to implement the same logic in real time, then you have to use these timers. Like if I want to put the timer here, so what I'll do is here also I can implement like timer. After launch, I want to put a add timer, constant timer. Say if I put 1,000 milliseconds is 1 second, right? So after each action, I want to put some. Let's copy and paste. Right. Same thing, I want to do it here also. But the problem here is there is no logs, nowhere it will display how much time it is waiting. That is the problem with Jmeter timers. In load runner, you can see how much time you are waiting, but here it will wait. Okay, it is waiting, you can see. In this is coming from fragment. In that also have included timer. So instead of putting, see if I'm if I want to wait a constant timer, like no, after each action, I want to wait for 1 second, right? Instead of putting like this, if I put remove everywhere, remove, here also I'm removing. What happens if I want like 1 second for all transactions should wait, right? Go back to your actual script. Instead of putting action to action, what happens if I add a timer at the thread group level? Like here. Let us say I'll wait for to see the difference 3. It is applicable for all the transactions inside the thread group. You can see it will wait for 3 seconds, then only the launch. Again 3 seconds. Instead of giving each and every, if I put that at the last or at the thread group level, that is applicable for each and every transaction. If I put that under one transaction, it is applicable for each and every request under one transaction. So instead of putting, you can put a constant timer, add at the thread group level. It will make sure that each and every script will, each and every action will pause for whatever the time. So this is called constant timer. So there are other timers also there. Like, if I want to implement a random, uniform random timer, right? You need to mention the maximum and minimum. Like, here I would put constant delay, random maximum. Like, I want to put like maximum, it should be 4 seconds and 1000 milliseconds. That is 1 second. And when I remove this, so it will randomly calculate between 4 to 1 second and it will wait. That is uniform random timer. Randomly it will, this is a real time, right? In real time, we don't know, right, how much exactly you will wait. And other timers are also there. Like you have a Gaussian random timer when it comes to delay. Gaussian, we have Poisson random time. So here the difference is in Gaussian random timer, you need to mention the deviation. Like, if I put like 1000 and offset in millisecond, they take it as a maximum. So what it does is it will take like 5 seconds plus 1 seconds. How much? 6 seconds, right? So it will take any number between 1 and 6. Minimum 1, maximum 6. So in Poisson random timer, if I put this is as lambda in millisecond 1000, constant delay offset in, let us say 5. So it will take between 5 minus 1, how much? 4. 4 and 6 it will take. That is the difference between Gaussian and Poisson. Based on the formula, that's it. Gaussian formula is this constant uniform random is between 1 and 4. In Gaussian, it will take between 5 plus 1. How much? 6. 1 and 6. This is minimum and maximum 6. Here, the minimum would be 5 minus 1, 4. Maximum is 5 plus 1, 6. So 4 and 6. That's how these timers will work. So we can use any of them based on our requirement. Let me put this. But the only problem in Jmeter is you can't see anywhere how much time it is waiting. That cannot be displayed. Even if I add a dummy sampler, you can't see that timer. Maybe in the future they will update this. You can sense the delay time. Completed, right? So the same way this will work. So based on this formula is different, this formula is different. This is about wait time. There are other timers in Jmeter. It is not just wait time. If I want to implement some logic, right? Say for example, here, let us say, here our script is what? First is launch, right? So our demo application launch, then you are searching for city. After that, you are selecting, right? Choosing any of the airline. Then you are clicking on purchase, right? Now, when I run this with 100 users, right? So normally, this is a scenario, right? So this is a scenario, and I'm running with multiple users. Let us say I'm running with 100 users. So actually, when I put 100, it will act as if 100 users are trying to access the application, right? So let us say the multiple users. Like that, let us assume you have total 100, let us assume, right? Now, when you run this scenario with 100 users, how the users will behave? The user one, this may be launching. Second user may be clicking on this. This user may be clicking on this. So this is called concurrently accessing. So when I run, you can cross check. So when I run with this, let me run with 5 users. Let me remove this till time also. Right now you can see. Okay, I need to put the users, right? Did I put that? Okay, let me put that users as well. User number we can see here, even in include also an add. Let's save this. Now I'm running this with what? 5 users. See, user one launches, user two launches, user three. After that, user three is launching. Then user five is launching. By between that, user one already selected the product, right? And user three also clicked on login something. This is how it will execute number of users. Now here the requirement is I want to do a spike test. Like here I want to know all the users, all the users should hit this button purchase at the same time. All the users, if there are 100, all the 100 users will hit this button at the same time. They will start they can start at any time, but they should come to a point and they should wait. When all the users come to this point, they should hit this button purchase. Okay. Then how do I implement that? So each user one comes, launches, search, choose. He should wait for the another user after choose. User three, launch, search, choose. It will wait for another user. And like that, it will wait. It should wait until all the 100 users come to this point. Once the 100th user come to this point, all 100 users should hit this purchase button at the same time. Any button, it can be purchase or anything. This is the client requirement. They want to see at a time 100 or 1000 people will hit the purchase button. What would be the impact on the server? Here it is not possible using normal this thing. So here what I want to do, I want to click on this update. Let us assume this update button. Okay. Uh, with all the 5 users at the same time. Then here you'll add timers. There is something called synchronizing timer. It will try to sync, or it will uh, make other users wait until all the users will come to this point. You can see select product, select product. Last one is one update. Update will be hit only all the users at a time. You can see. Update 1, 2, 3, 4, 5 users are hitting update at the same time. But if you see here, select, add details, select, or selecting in a random way. You can see add details here, random way. But when it comes to update, all users are waiting until the last user come in. Then only it will hit. If you want, I'll change this, ramp up into 15 seconds. Now I'll see. Launch, see add detail. This update will be hit only when 5th user come into the picture. Now you can see. Once the launch, 5th user logged in, then only update is hit. I think we can use another listener to understand this. There is a listener called active threads over time. This will show like how the users are logging in. Let us try to understand on this. Yeah, first user, then second user. Once the third user come into the picture, then or 5th user, then only you will see this update will hit. Right? So in real time, when all the users will hit at the same time, there should be increase in what? Hits. So if I add hits per second graph, you can also add many graphs like hits per second. Yeah, hits per second. These are all dummy only, but when all 5 users will hit, you'll see the increase difference in the hits per second. At the last, you will see sudden spike. Since this is a dummy, it is not giving any response normally. Okay, so in real time, see, you can see all the 5 users, once they reach, then only it will hit this update button. This is called synchronization timer. Yeah, you can see sudden hit. Sudden increase in the hits. So this is another type of timer, synchronization timer. So using timer also you can achieve throughput also, like the timer. If I make see, we have seen constant throughput controller, right? There, if you are expecting this many number, then you can use. But If it is based on the response time, you want to delay to achieve the required total number like throughput, then you can use constant throughput timer. So here, what I'll do is I want to in these many requests per minute only it should execute like that. If I want to put, I'll say this thread only. So I want to achieve per minute per second one means per minute how many 60. So you just have to calculate that. I want to achieve only 60 per minute. That means per second one. So if I put that here, the synchronization timer, I'll remove. Update should, I'll just add this to update. It will make sure that this update will be executed only 60 times per minute. So here, let me run this for 60 seconds. Okay. So I'll put one user. Let me per user it will take. Okay. So let us try this. 5 ramp up. I'll put. Okay. And let me put 10 seconds. Now I'm running this for 60. I'll put infinite 60. Now you'll see. Let me add a summary. Listeners summary report. Right. See, synchronization timer is totally different from ramp up time. Ramp up time is what? To start. Right here, each user will start. In the ramp up means within 10 seconds, all the users should be onboarded. This is for onboarding or logging into the application. Synchronization timer is after logging in, I want hit all the users a particular button. There's a lot of difference between ramp up and synchronization timer. If I put 0 as ramp up time, maybe all the user will try to log in. Okay, at that point it will work, but I want to hit a particular button, not just login. After logging again, they'll work individually. Even if I put 0 seconds here, all the user will launch at the same time. But after launching, they'll concurrently they'll access they based on their response time. But uh, when I use synchronization timer, all the users will wait until the last user come into the picture, then they will hit the button. That is the difference. Now let me run this for 60 seconds. Okay. We want update, right? The response time is what? In milliseconds. So I said this update should reach 60 samples per minute. We have completed 1 minute duration, right? If you calculate all these updates, it will be equal to 60. Update 121, update 2040 plus 21 60. Okay, so it will try to reach constantly, and if you want to get the exact figure, then we'll use precise throughput timer. Precise is it will make sure the exact figure what you want to do. There is a difference between precise and constant. Constant will try to adjust the time and try to reach the goal, whatever you are giving. Precise is like you can put the target exactly, it will try to achieve in the period what you want to achieve. So I'll put test duration 60 and the throughput period in 60. Target throughput I want to achieve 60. Okay. Number of threads. So I'll try to run with one thread only. I've removed that. It says throughput timer. Add this at the transaction level. Let us see this. We have put only one user. I think 60, 60. Throughput period 60. I want to achieve 60. But if the time is complete, it cannot achieve. So I need to increase the time, because the time taken to complete one iteration, I think I'll put this to instead of 60. Let me put this. How much we are getting? Around 20, right? So here I'll put 15. Okay. Now you'll see. Because it takes, you need to consider the time taken to complete one scenario, right? So each one is taken, let us 1 second. So 1, 2, 3, 4, 5, 6. So 6 seconds it takes only to complete one iteration. So in 1 minute, it can maximum it can take 10 or 15. But I'm giving the target more than that, it won't achieve. It will try to reach the target nearer target. So if I add this to direct to this request, let us see the difference. Here earlier I have added to the transaction. Now directly added to the request. We'll see the difference. Yes. Try to reach the exact figure. Instead of 16, put 19. Then we'll see. Now I increase to 90 seconds. Let us say more than 1 minute. So if the time is left, so it has to execute, right? So here the thing is, it will try to reach the minimum of that number. But if the time is permitted, it will execute. That is with the precise or throughput timer. Okay, here see per minute 15, right? Per minute 15. So we have executed for how much? Around 90 seconds. So here I have given 15 should reach in 60 seconds. So it has reached uh, 15 in 60 seconds. After that, like how much left, based on that it is executing. So if I run for 2 minutes, it should be like 30, something like that. That's how it will take. So I'll put 120, 5 seconds more. Uh, Let us see this. It is per minute, right? When I'm running for 2 minutes, per minute, 15 minutes, 2 minutes, it should reach 30. Throughput period, okay, we said only 60. Test duration 60, but here I've given 120. Yeah, it is executed more than 2 minutes, right? 2 minutes, 5 seconds. So It got one extra. So these are the timers. You can practice this. And we have covered almost all type of elements. We need to cover these things, config elements, right? And these things. After covering the config elements, we'll move to the next application, that's the retail application. In that, we'll do the advanced level logic implementation and everything. Okay, that we'll see tomorrow. Yeah, see you tomorrow.